The search for life beyond Earth is one of the most captivating questions in modern science. Since the first astronomical observations were made, humanity has wondered whether we are alone in the universe. Now, with advances in technology and space missions, this question is closer to being answered than ever before. One of the most intriguing and exciting recent discoveries in this search was the identification of an exoplanet orbiting Barnard star, the second closest star to the solar system. The discovery offers new perspectives on exoplanet research and raises a series of questions that may someday help us better understand the conditions for life on other worlds. What is Barnard star? Barnard star is a red dwarf star located about 6 light-years from Earth in the constellation Ophiuchus. While it is relatively close in astronomical terms, it is only visible with powerful telescopes due to its low luminosity. This star was discovered in 1916 by astronomer Edward Barnard, and since then it has been the subject of study to better understand the characteristics of red dwarf stars. One of Barnard's star's peculiarities is its high proper motion relative to the Sun. This means it is moving rapidly through space, making it one of the closest stars to us. Because of its proximity and characteristics, it has been an important target in the search for exoplanets and the discovery of a possible planet in its orbit could provide us with clues about the formation of planetary systems around such small stars. The discovery of the exoplanet in 2018, an international team of astronomers announced an extraordinary discovery: the identification of an exoplanet orbiting Barnard's star. This planet, named Barnard's star B, is a rocky giant, about 2 times the mass of Earth, located in the habitable zone of the star, which is the region where conditions might be favorable for the presence of liquid water on its surface. This is a crucial factor because liquid water is considered one of the key ingredients for life as we know it. The planet was detected using a technique called spectroscopy, which analyzes the changes in the light from stars caused by the presence of planets. When a planet orbits its star, it exerts a slight gravitational force on the star, causing the star to wobble slightly. This movement can be detected by telescopes, and this is what the scientists were able to observe to confirm the existence of Barnard's star, B. Although it is in the habitable zone, the new exoplanet is a world very different from Earth. Barnard's star B does not have a thick atmosphere and seems to be very cold, with temperatures that may reach 170 degrees Celsius. This extreme cold would be a major challenge for any form of life, but still, the discovery opens up new opportunities for the search for habitable worlds and for understanding the different types of planets that exist in our universe. Implications. For the search for extraterrestrial life, the location of Barnard's star B in the habitable zone is undoubtedly one of the most intriguing aspects of this discovery. Being in the habitable zone means that the planet could, in theory, have conditions that allow liquid water to exist on its surface, a fundamental element for life. However, the lack of a thick atmosphere and the extremely low temperatures observed suggest that the planet is unlikely to support life as we know it. This discovery raises important questions about what is really needed for life to thrive on another planet. Is liquid water enough, or are other factors, such as the presence of a protective atmosphere and energy sources like solar radiation, equally crucial? If Barnard's star B cannot sustain life, what does that tell us about the chances of life on other exoplanets? Additionally, the research on planets in habitable zones helps expand our understanding of the conditions necessary for life. It allows us to refine the techniques used to detect exoplanets and identify those that truly have the right conditions for life. The possibility of finding other worlds like Earth is one of the main motivations behind space exploration, and discoveries like Barnard's star B help us better understand the complex interactions between stars, planets, and their atmospheres. The detection technique, the importance of spectroscopy. The spectroscopy technique used to discover Barnard's star B is one of the most important methods for detecting exoplanets. By analyzing the light emitted by the star, scientists can identify small wobbles caused by the gravity of the planets orbiting it. These wobbles are very subtle, but can be measured with precision, allowing astronomers to determine the presence of planets, even if they are not directly visible. In addition to spectroscopy, other techniques are continually being developed to improve exoplanet detection. One such method is the observation of planetary transits, which occurs when a planet passes in front of its star, causing the star's light to briefly dim. By combining these various approaches, scientists can detect exoplanets in distant star systems and study their characteristics in more detail. The future of exoplanet research, the discovery of Barnard's star B, represents only the beginning of a new era in the search for exoplanets and perhaps extraterrestrial life. In the coming years, more advanced telescopes, such as the James Webb Space Telescope, will be able to study exoplanets with even greater precision. The James Webb, in particular, has the ability to observe planetary atmospheres, which could provide us with crucial information about the atmospheric composition of distant worlds and whether they have the necessary ingredients for life. Furthermore, future missions may help us further explore the region around Barnard's star. If Barnard's star B has other planets in its orbit, as some simulations suggest, those planets might present very different conditions, and possibly more suitable ones for life. Therefore, the exploration of this star system, and others like it, will continue to be an area of intense scientific research. The impact of the discovery of Barnard's star B, has a significant impact not only on astronomy, but also on how we understand the universe and our place in it. Each new exoplanet discovered broadens our knowledge of the diversity of worlds that exist in the cosmos and provides clues about how planetary systems form. Additionally, identifying exoplanets in the habitable zone and studying their characteristics helps us better understand the conditions necessary for life. While we cannot say for certain whether there is life on Barnard's star B or any other exoplanet, this discovery brings humanity closer to one of the most fundamental questions in science. Are we alone in the universe? As our space exploration technologies advance, it is possible that we will one day find an answer. Until then, the discovery of Barnard's star B will continue to be one of the most fascinating contributions to the study of exoplanets and the search for life beyond Earth. Conclusion. The discovery of the exoplanet orbiting Barnard's star is one of the most important astronomical breakthroughs in recent years. While this planet may not be capable of sustaining life, its location in the habitable zone and the techniques used to discover it have profound implications for the search for other habitable worlds. With the help of telescopes and future missions, like the James Webb, the exploration of exoplanets, and our understanding of the conditions necessary for life are more advanced than ever before. Barnard's star B may not be home to extraterrestrial life, but it opens new doors for understanding what makes a planet habitable and brings us a little closer to answering one of humanity's oldest questions. Are we alone in the universe?